It's going by 1/2 and then it goes to 64.
Yeah. You gotta label them.
Okay, so you recognize that this on the board.
But it's not linear. Linear goes.
But it could also decrease.
The graph is going straight down.
Yeah, it's still a straight line.
But
With the pattern.
think about it. It's not going at a constant rate,
That's true.
and it's not growing exponentially.
Not going exponentially. Oh,
It's
yeah.
like in between those two.
It
So
is
it's,
growing exponentially because we have an exponent equation.
yeah, but it's dividing by 2, so it's like decreasing.
Oh, remember, you know. I'm not trying to.
1 is 64 and 2 is 32.
Three is 8. Then 4 is, well, 4. 5 is 1. 2. Then 6 is 1. Then the rest are just decimals. Yeah, that means it's inverse. Inverse variation?
Yeah.
Inverse variation is
So it's called micro.
So after.
I have grown. Yeah. It should be.
What should we put as a title?
Stephanie, what do you think the title should be?
Making smaller values. Okay. So does our graphs look the same?
How much is, what's the area?
Let's just get started.
Instead of the area growing, like for example, instead of multiplying by the growth factor, it's decreasing by like it's dividing by 2.
One is what is it?
Yeah, that's what we could
So
say.
multiplying by 2 is like.
It's different because instead of multiplying by 2, it's dividing by 2. Yeah.
How else can you multiply it besides dividing by 2?
half.
By fractions.
So
That's like a growth factor. That's like 1/2. We could have done that too.
inverse variation. We could have done that.
How did you just get the 1/2? How did you just get 1/2? I asked you besides dividing by 2, what else can you do?
Get half.
So where did the half come from?
Because like if you multiply something by half, then it basically means you're dividing by 2.
Okay, it's not cheaper, but how many? So how's negative number of balance?
Does it ever stop?
How is the pattern of change in the area never going to keep the pattern between these? You just
Decreasing.
So we have to quit. And it's similar
Think your
because
graph is missing anything, Elian?
labels,
What?
labels.
Should every graph have labels?
Those would help. How do you guys think it's similar?
because they
It's two.
it has a
And the number is raised to
this one's increasing by 2.
the number is raised to a
We
power.
could also do the thingy that when you multiply by half instead of dividing by 2.
Oh, it's it's a fraction instead of a whole number.
Yeah. But I also thought of the graph because it looks like exponential looks like this, and then this one looks like this.
It's going down instead of going up.
They're kind of similar in the graph.
Okay. But is it ever gonna? You just get another number.
Okay, so
What are you noticing happening to these numbers?
Says how the pattern of change.
They're decreasing? How are they decreasing?
How the pattern.
Okay, so it's being divided by 2, or you were saying it's being cut in half every time. Is this gonna, can this pattern continue? It's gonna continue? Does it ever stop?
I think that it will stop because at one point it will get to 0.
Can you repeat that a little louder, please?
I think that at one point it will stop because it's going to get to 0.
What do you guys think? Think it's gonna get to 0? Why don't we test it out? Let's take your last piece of data. Let's see what happens. Let's make some observations.
if they look similar and
And keep on going.
if the one that we used to do with
No, just numbers keep getting added to it, but it doesn't end.
What do you mean numbers get added to it?
There's like more zeros because there's more zeros added to it.
There's more zeros after the decimal point? What do you think that means then?
It will get to 0.
It's not going to get to
It's
0?
not going to get to 0
Why not?
because the number will go on forever and ever.
So even this number, as tiny as this is, can this number still be, can you still take half of that number?
Yes.
We have a number of reasons how we equate as 20.
you multiply it to
No, but
with
you
the
have a
power
number
of
raised to a power.
number.
We have a question over here. That don't
So
Ask them.
Then we would the number of cuts will keep on going.
He said, is it possible the number of cuts are going to keep on going? Yes. We just had that discussion. Come over here, let's listen to what this group has to say. Share this discussion we just had with these two. Beth had a great question. He was asking, is it possible? How did you say it? Say it again.
Oh, that you have like it ended right here, would it keep on going?
What do you guys think?
It will keep on going, but more zeros will be added to it.
Yeah, it's because every number can always be divided. It'll keep on going.
How did you ladies figure that out?
Because we took the number that we had for 10 and we keep on dividing it by
Say it
2.
again a little louder with your very quiet voice.
Because we got the number that we had for 10 and we continue dividing it by 2 and we continue getting smaller by the zeros getting added to it.
So can you show them what you did? You guys can come a little closer.
And we're actually, there is what we are going to call this.
So what we did is that we grabbed the last number that we had and we started to divide it by 2.
I know you can start off quite high. What's the 4? They went on 4 and
And what was happening was that every time the number got divided, and once we would get a new number, it would get divided too.
I actually would have my checkers my grade. I actually would have my checkers my grade. Yeah, because mine would.
Oh, I see.
What is over the end? Wait. What have you right here? Hey, one of you can do this first. You're real slow.